morning to everyone present. Thank you all for coming. Welcome to the Simulation Hub webinar on designing and modeling detailed HVAC systems for load and energy optimization using Buildings AI. Thank you for joining us. This webinar is ideal for HVAC engineers, designers, MEP consultants, those involved in building HVAC load and energy consumption analysis. Today's webinar is part of a series in design and modeling of heating, ventilation, and air conditioning systems. Today, in the first part, the agenda is to demonstrate the detailed HVAC modeling using Buildings AI platform. I'm the host for this webinar, Manas. I'm a member of technical staff at Simulation Hub at Buildings AI. I'd like to introduce the speakers. So our guest speaker is Surbhi Joshi. Surbhi is
sorry to interrupt, Man. Are you changing the slide? Because we are seeing a title slide right now.
Oh, yeah, sorry. Yeah. Thank you. Thank you, Swapnil. I'll just continue. Yeah, so our guest speaker is Surbhi Joshi. Surbhi is a building energy and life cycle assessment expert with over 15 years of professional experience in energy simulation and analysis for high performance buildings. She co-founded Building Calc, Pune-based consultancy in 2017. After spending nearly a decade working in the United States, Surbhi holds a master's degree in building science from Georgia Tech and a bachelor's degree in architecture from Chandigarh College of Architecture. She's the lead author of the AIA guide, Building Life Cycle Assessment in Practice, and has presented at numerous national conferences in the US, including SimBuild, AIA National Convention, and NRMCA Convention. Our speaker from Simulation Hub from Buildings AI, Swapnil Dindorkar, is an engineering simulation professional at Simulation Hub and the product manager at Buildings AI. He has more than 14 years of industrial experience in the application of flow simulation for the design of solutions towards building physics and electronic thermal management. He's currently in charge of the portfolio at Simulation Hub for products and solutions within CC Tech, which cater to sectors of building physics and whole building performance modeling. He has a background in mechanical engineering with professional certifications in areas like project management, digital business management, and the design of net zero energy buildings. Those of us who are joining us for the first time, I'll give you a brief introduction to Simulation Hub's product, the Buildings AI platform. So Buildings AI is a platform for HVAC load calculation and energy modeling powered by agentic AI. It's powered by Energy Plus Simulation, the Energy Plus Simulation engine in the back end. We are partnered with Autodesk. The Autodesk platform services is what we use for our data management and visualization. Buildings AI supports files and models from Autodesk Revit. We have that integration. We also use the AWS cloud for running our energy simulations and other cloud services. We also offer the Simulation Hub API as microservices. So Buildings AI is an AI-powered human-in-the-loop workflow for whole building simulations, part of which one of the features that we have for it is the PDF to BIM module. It's a computer vision model and deep learning model that converts floor plan drawings into BIM models. And this significantly reduces your manual work automatically. As other parts of buildings AI are the load calculations, sizing of and selection of HVAC systems is something you can do with the platform. Energy simulation is part of it. You can do the whole building energy analysis with this. We also have Buildings AI Assistant that is available through the entire workflow. You can query your BIM models, your simulation setup using natural language and have it execute commands on your behalf, set up materials and more. We also have Report Assistant, which can help you customize your report automatically just based on natural language inputs. Apart from that, we also have the CFD module for our thermal comfort and indoor air quality assessment. So yeah, we can get started now. If the attendees, if you have any questions, please post them in the chat or the QA window. Survi, you can take over now. Thanks.
Thank you, Manas. Let me start my screen share. So are you able to see my screen?
Yes.
Great.
Yes, yes.
All right. Hi, everyone. I am Surabhi Joshi, and Manas has already given my introduction. I come from an architectural academic background, but I have spent most of my life in most of my professional life in doing energy simulation. So whenever we talk about as energy modelers or analysts, whenever we talk about why are we attending a particular webinar or seminar, we think about what's the logical reason. So I thought we'll start with why are we all here? So why are we all here? We are always looking for ways to make our work more efficient, more productive. And so this particular webinar, I think all of us are here to explore a new tool, a tool which we are hoping will be simpler, more flexible, faster, and easier to use. So that's primarily, I would say, that most people are looking for. Now the question arises, we've been doing this for a while. Energy modeling has been in place for over 2 decades, even before that. And so there are already a lot of HVAC design tools, HVAC or energy modeling simulation tools. What is the need to have one more tool to help us model buildings for energy or to design HVAC systems? So I say, let's go back right about 50 years ago. 50 years, why 50 years? Because that was a critical time when, we had those 1970s energy crisis. So in 1970s, there were a lot of other things, but something other that was going on was 1970s is when the centralized air conditioning became very popular. And, it was common for people to have it in offices. Getting air conditioning at home was catching up with that. And so in 1975, that was the key year when DOE, Department of Energy in the US, they came up with the first energy efficiency standards. And so, at that point, the systems were simpler. There was constant air systems. Slowly, as we moved to the 1990s, there was the VAVs, the variable air volume systems, and eventually the VRFs became popular. And then when you move on 2 more decades, we had more complex systems like energy recovery system and heat exchangers and geothermal systems. And on top of that, the Internet of Things had caught up. And so we were designing as building facility managers or as HVAC designers, we were designing complex controls for our HVAC systems. So, so why do we need another tool? I would say that the HVAC industry has moved quite a lot from when it started to where it is now, right? Now, why did this evolution happen? What caused this evolution, right? So this is just something that we see very often. Every other day we come across newer systems in our projects, and we're trying to figure out how to model them in a better way. We're trying to figure out workarounds, and I think that's the reality. So quickly, just to pause here a little bit, and this is, most of you must be aware of this, but let's just quickly answer that in our chat box. So which ASHRAE standard governs energy efficiency in building design? Please enter your answers. So you should be able to see the poll on your screen, a pop-up window. All right. I'm going to end the poll now in a few seconds. Okay. So yes, majority of people have voted for ASHRAE 90.1, and I'm glad to see some votes for ASHRAE 189.1 as well, because that's another standard which has a lot of guidelines for how to go about building sustainability in general and how to go with each building systems, lighting, HVAC, everything included. So bingo, both the answers are correct. All right. So in the last slide, we were talking about the evolution of HVAC system and why they evolved. So what was the reason behind the evolution of HVAC systems? It was majorly as the systems became more complex, the codes were driving them. Because if you look at this graph that is on the screen right now, you'll see that this graph on the x-axis represents the timeline, and on the y-axis it shows the EUI, the energy use index. So let's say the 1975 standards was 100 EUI. So if you follow through, every year we were almost going down about 5% in terms of EUI. And till 2016, we had already come down to around 45 EUI from 100. And if you look at current codes, it's probably below 40 right now. So there has been a lot of push coming from the codes, the standards, and simultaneously with the rating systems like LEED, that has pushed us in designing more and more complex systems, which will save us energy. Now, what is HVAC's contribution in a building in terms of energy? So if we've mostly all modeled buildings and seen the pie charts where we see the distribution of energy, and majority of the savings that come from an average standard building is from the HVAC system design. So if we can design the systems in a much efficient way, we can design systems that are more appropriate for the weather or the climate of the place. There is a huge potential that is coming right out of HVAC, which contributes directly to the building loads and to the overall energy consumption of buildings. So this is a data point from DOE, and about 40 to 60%. The HVAC alone accounts for 40 to 60% of the total building energy savings, which is a huge piece of the pie. And that's why it is critical that we have the tools to design them well and to be able to model the systems that we have designed. So coming back to the same thing, that it's not just how we select the most efficient ER or CR values. It's also about how all the equipment work together, along with the control systems and the equipment, how they all come together and form a system. And so it's not just about equipment selection. The issue is more about how well a system is designed for that particular use case. Now, so far, if you look at the evolution of HVAC, we've talked about HVAC's evolved because of stringent codes, and they are becoming more and more complex to cater to the requirements of the code, to be more energy efficient, to be more to reduce the carbon emissions coming out of the usage of HVAC. So that's the current situation. What is now emerging is how are the future HVAC systems going to evolve. And here you see that I'm sharing two graphs. One is for India and the other one is for USA, assuming that majority of our audiences are from here. So I think the biggest driver for the further evolution of HVAC systems would be climate change and the actual changing climate. So if you look at the graph on the left, which is for India, the timeline is on the x-axis, and the y-axis just lists deviation from the average temperature. And so if you look closely and compare both India and US temperatures, you'll see that till 2000, the average temperatures were fairly okay, and they were either below average or right at that level. But as you go beyond 2000 all the way to 2025, we have mostly been above average. And this is a clear proof why we have higher temperatures. And on the other side, we have more stringent codes. So the future challenges of the HVAC system industry would be to still adhere to the codes and standards and the guidelines that they establish in terms of energy savings. Yet we will have more extreme temperatures to deal with and to design our HVAC. Another component of this would be that the climate is not very predictable. So another component that will be a challenge for the HVAC industry would be to design for the changing climate. There's some places which were getting more rain, had higher humidity, and there is less rain. There are other places which were designed and the systems were designed for lower humidity. So we need to have systems in place and design methodologies in place to be able to design flexible systems, which are adaptable for future climate changes. So that's what I think has driven the evolution of HVAC systems and why now we are seeing more and more complex systems, which is making our life more challenging because we're supposed to design and model these systems. And let's see if we have the right tools to model them. All right, another poll here. So I think I've shared my point of view so far. What do you think are your biggest frustrations when you are designing or modeling the HVAC system? Okay, poll is still open. We're seeing a lot of interest in time-consuming manual inputs that I would see is a big pain point. Excellent. I think we've got really good insight into what we were already assuming. I would say that I completely agree that there are so many manual inputs which are tedious and take away time from our analytical brain. That if we could have better ways of entering data, that'll be great. Another hit here was poor coordination between design tools, which is exactly what we're going to talk next. So I'm going to end the poll here. Okay. So the point that I'm trying to arrive at is that with so many complicated systems, so many complicated control strategies, which we are now bound to have because of the rating systems, or in future because of how the climate is changing, we need to be equipped. We need to be equipped with the right tools to be able to do that and to be able to do that in the most productive and efficient way. So as the HVAC systems evolve, the tools that we have been using need to evolve as well. In my experience, if I talk about the tools that I've used in the past, so many times in energy modeling, I've used eQuest quite a lot, and I still really respect that tool. It's a great tool for quick calculations and quick glimpse into what's going on. But I remember that, with eQuest, there are always workarounds. You talk about underfloor air distribution systems. We had a workaround in place. Direct outside air systems is another system which has had its issues in being modeled with various energy modeling software. And then other than the capability itself, even popular systems, the way of the input is not very intuitive. So let's talk about how tools and workflow are we dealing with. We are mostly going for one primary tool, which would be modeling our whole building, and then depending on the system type, then we say, okay, maybe there is another tool which will calculate all the data and then enter the data from that tool into our primary tool. Then many of us, I'm sure people who are online here, have their own customized Excel sheets, and then there are others who are the techno gurus who are using Ladybug and writing their own codes, and coming up with their own tools. But what happens in doing all of this is that we are constantly juggling between many tools to get our data, and we are not sure whether there are possibilities of a lot of human error in when we talk about these tools. So there has to be, the current system is either fragmented because we are doing a lot of things at different places, and then the type of systems that we can model is very rigid. There's a particular, let's say, system A, which only can allow like n number of diffusers to attach to it, or n number of AHUs that will attach to it. So there is less flexibility in what can be modeled. And also because of the way the parameters are input, there you have low visibility of how the actual system looks like. And finally, when we are trying to make changes, which are always, part of the process, there's very little in terms of, it takes a lot to actually update a system. So what do we need? And here I just wanted to emphasize that a lot of time, if we could see how the system is and what is connected to what, it'll solve a lot of problems and give us as energy modelers or HVAC designers a lot of clarity. So what does an ideal tool look like? I think an ideal tool would be a streamline tool, which would be able to bring together a lot of things in one place. It would be flexible enough so that if we've modeled something in the design development stage, we should be able to easily update it for the construction document phase. And then we should be able to look at it in one go and be able to QC or quality check, quality control the model as quickly as possible, so that we don't waste time in that. So finally, we are, just to wrap up, we have a current workflow of where we are using several different tools and workflows to arrive at our results. And that's something that is not very conducive to for us to work efficiently, and also can lead to human errors. And so we need a system where we could bring everything together, have more clarity, and have confidence in what we are modeling in terms of tools. So I think from here on, I'll pass on the presentation to Swapnil, because let's see the potential for what we have here in terms of HVAC Canvas. I would say that I'm really excited about the possibility of HVAC Canvas being included in buildings AI, and then to top that, the capability of AI to end our misery of enter. All right, over to you, Swapnil.
Right. Thank you, Surbi, for giving a very good foundation in terms of first understanding why HVAC design or HVAC itself forms a critical part in terms of saving energy savings for a building design, and second, giving a good overview of based on your vast experience, what is the current workflow and what are opportunities in that to basically improve So now what I'll do is basically present one of our new features in Buildings AI, which forms part of the modeling side. Like we will be probably having a series of this webinar, which will focus later on the design side also. But what we wanted to introduce today is the modeling side of HVAC systems within building performance analysis. So let me share my screen. All right. I hope my screen is visible.
Yes.
Yes, visible.
Yeah. Thanks. So, I'll start off where should we basically hand it over in terms of showing what all forms part of current HVAC system modeling, how it applies to the building design, and how the process is basically fragmented. So the critical feature that we wanted to present in this webinar is basically a canvas workflow where we are able to model custom-made HVAC systems within Buildings AI and apply them to the building model as a whole. And this is where we try to bring together the entire HVAC system visibility, have a clear understanding of various sections, the AHU side, the plant side, how we apply them to zones, all together seen as basically as a canvas where users can modify it, and even with AI assisted workflow, they can make the process easier than the current established process. And there is easier way to basically modify your custom made HVAC system network, debug them or change them, carry out design scenarios based on different configurations, and how we have placed this as a module within our existing Buildings AI workflow. So basically, we have a canvas which is upcoming module, and it helps to design bespoke HVAC systems, understand how they perform in terms of energy savings, in terms of the load calculations, and iterate different configurations of HVAC systems or networks. Now, just to give an overview, Buildings AI, I think we covered in many of past webinars also, but for audience that is new to this particular application, it's basically a AI powered autonomous simulation platform meant for whole building performance simulation. And we have added one module at a time. And right now it's there. The tool is capable of handling multiple inputs for building model, doing a standard load calculation and energy analysis, as well as now with this new module, it is able to do bespoke HVAC systems also. It is a complete app-based workflow hosted on browser, and all the calculations are on cloud, so you don't need any system requirement as such to start using the tool. So it can be operated through browser. Overall, just a quick uh, glimpse of the workflow for Buildings AI. It starts with identifying the site location from which the app gets the local climate zone and compliance standards, bringing in the building model in various forms. We have multiple ways to bring in a building model, right from basically a 2D layout, a Revit model, or even drawing them as a from scratch using Sketch. Also, we have multiple options, right from a basic load calculation to custom made HVAC system, which you design through the canvas. You can do HVAC load calculation, see the effect of proposed system, how they perform, do an entire year energy calculation to see avenues for energy savings, change your design uh, from the geometry side as well as from the HVAC design side, see the effect and carry out multiple design scenarios. And we have a report which is basically a standard template based report, as well as using the chat based feature. We also have AI assisted report module. Now, coming back to the HVAC specific applications within the tool, We basically have three modes of doing HVAC system design. We have a conceptual mode where we don't go into details of the HVAC system. We just basically do ideal air loads, which is like just finding out the peak loads required for the system. We have a middle path where we basically use pre-loaded or already pre-compiled HVAC schematics, which we refer to as templates, and then directly apply those commonly used templates to the zones of the building spaces. And the third, which is very complex and meant for those who deal with bespoke HVAC systems designed from scratch for the particular building type, and that is referred to as HVAC detailed, which gives full control of basically building your entire HVAC system right from ground up, and using different components like air side components, plant side components, configuring their properties as well as their schedule sequences, and then building together a complete HVAC system for a particular geometry or building type. That is referred to as HVAC detailed, which can be done using the HVAC Canvas tool. These basically have different requirement, like someone who wants to start off with a quick schematic or early stage design can use the HVAC conceptual. Common building types or already packaged systems, if they are installed, then we can go with the HVAC schematic. And again, like I said, custom made HVAC systems for very complex building designs, we can use the HVAC detailed. So how does the workflow look like? Basically, we're taking a clue from what Surbi just explained in terms of what are the challenges in the workflow. So what we have tried to do in the Buildings AI application is basically make it very simple in terms of the steps required for building a energy model for a particular structure. So what we start off with basically bringing in the building configuration, which is in the form of geometry of the building type. Then we have added one interesting feature is we wanted to give the full visualization control to the users of the application. So we did not want to give a feel of basically handling the different spaces and different data of a building using sort of a lists or handling sort of a Excel type of workflow where you are basically dealing with a different type of data. So we wanted to bring in visualization where actually the users are getting to know what space lies in a particular store level of a building. Where is it exactly, like when they modify a particular space type or material type of wall, or even if they apply a particular HVAC component to a room, they get to see basically what they are doing in terms of visualization. So we have a basically zone visualization viewer, which gives you an idea which particular space you are selecting, how the zones are basically being grouped together into forming a zone group, which is having a common HVAC system applied to it. So that is what we call as selecting the zones. After that, we have a list of HVAC templates pre-built along with their common operating properties that you can apply as well as edit. And the fourth step is basically coming up with your own HVAC system, which consists of the air handling units, plant side components, terminal units, and then building this up all together and seeing how it performs. So that is where the HVAC Canvas, the newest feature of our application, comes into a picture, and it has a large library of HVAC components. Finally, when all this is set up, then the user can do either the load calculations as a quick simulation, or they can also do the entire building energy modeling to see avenues of saving energy for the entire performance. So our basically aim is to have a single integrated workflow, and our main focus was on bringing in the models, the building models in the easiest possible way, have a very strong emphasis on basically visualization. So whatever steps the user takes, they are able to visualize, edit, customize to make better decisions for the energy saving avenue. So basically, our focus was on all these steps, and also how AI assisted workflows can help in making all these manual steps very easy, avoiding like long, lengthy clicks or creation processes. I'll also show you in the demonstration later how we have tried to simplify that. So now I've given you a overview of what we have tried to do. Now I'll show you a short demonstration of how this entire workflow happens in the application. So it's a quick demonstration video where what we have tried to do is basically load a already built-in template of HVAC system. We have tried to modify it by basically editing the water cooled chiller and adding in few more HVAC components for the different zones, and then carrying out a simulation with the building. So I'll switch over to basically a video. Just give me a moment. Just let me know once it's you are able to view the video. Just a quick go ahead will be right. Okay. So all right. So this is how basically the application looks like. Buildings AI. It will have a project dashboard where you start creating your new projects, the description, giving the climate zone and the local code compliance. Next is you select the location of the building, and once you have selected that, it fetches the local climate zone data. After that, the critical part is, like I said, bringing in the building geometry. So we have multiple methods, starting from importing a Revit file, also basically importing the 2D layout in the form of PDF, as well as creating from scratch for very simple early stage analysis. So in this current demonstration, we'll bring in a Revit file basically of the building type, which is uploaded from the, we can upload data from the local data hub also. Now, this is how the model looks like in Revit. I'm just showing it for showing you the different type of entities in the model, different space types that are there in Revit, set up as rooms, the space schedules that appear in Revit for the geometry. Now we are going to bring in this model into the Buildings AI app and create a new configuration. So this is how the building model looks like in the Buildings AI imported. For very simple Revit models, it works fairly well by importing as is. If the model is complex, we also have a import a sort of a module which cleans up the Revit model, brings in the space type and the envelope, and avoids the manual cleanup process. But that module is basically a topic of future webinars. We'll introduce you in the future webinars which we have for the cleanup process. So right now we have brought in the geometry with space types and envelope as well as zones. And we can see here we can apply different materials to different entities like walls, glazings, to set up how the building geometry metadata is. So once that is done, we have different space types to which we can assign different spaces or rooms in the model, which we can assign the space types. We also have the zones which have been imported from Revit, and different individual zones are appearing. We have a feature later where we can group these zones. So the building geometry is prepped up and ready now, and we go to the HVAC module where we build the HVAC system for this building type. We basically import the building configuration which we just created. And in the current demonstration, we are going with the detailed section where we customize the HVAC system for this particular building. We are starting with a feature called as grouping the zones. Since there are multiple zones and we know the purpose of them, we basically group them so we can apply HVAC system components to individual groups together instead of basically selecting one zone at a time and making this process lengthy. So we are creating new zone groups from the listed zones. And then we directly go to the HVAC Canvas, where we are going to first start with a pre-built template. So we have imported a template called VAV air cooled chiller reheat. And in this, we are going to basically modify a few things as well as add a few more components. For each of the individual components, we have a complete properties panel where you can basically edit the operating properties for individual components. So just a glimpse here how it is edited for the fan. Now we are editing basically the performance curves. We just click on that and we can edit the efficient parameters like efficiency, then uh, power, and as well as the motor efficiency. So all these are basically listed and they have their default values, but we can also edit them as required to customize the HVAC system. So we are entering the curves for the performance here and saving them as new edited components. Similarly, for the chiller, we are basically changing the type to the water-cooled chiller now. So I'm just highlighting what all can be changed. Basically, it's a completely customizable component library. We are also going to add the condenser plant from the library. We are going to add a cooling tower into that network and then connect them to the cooling plant in the already imported template. So this is how we connect different components. It's just a very easy canvas layout to work with. Another important feature is basically set points for the individual components in the HVAC network layout. So we can add individual set points as well for the components for managing their schedules. We for the other zone which we grouped as the food zone, we are also going to add a package terminal unit of heat pump. So now we have our entire custom network of HVAC system ready. Now we are going to submit it so that it gets like attached to the zone groups that we have and proceed with everything is ready now. So we proceed with the load calculations considering that HVAC system. So this is how we submit a new basically HVAC load calculations considering the local weather data as well as the geometry that we have for the building. The calculations are on cloud, so I mean they're fairly quick, and we get a result in the local data hub. And when we go to the result tab, we see facility loads, system loads, as well as individual zone loads for different type of scenarios, cooling, heating, as well as we have the split in terms of the different type of gains, like external walls, fenestration, solar, roof, floor, for that particular scenario that we have selected. Similarly, for heating, we have the different split available for the results. So this was about heat load calculation. Similarly, we can also submit a simulation for the full year energy simulation. So see how the energy consumptions are for the particularly built HVAC system. So annual energy calculations are done here, and this is how we see its results in the form of site energy breakdown for different components like lighting, interior, exterior, internal equipment, exterior, different type of equipments, as well as the monthly breakdown in terms of different month how the energy consumption is. So this was about like I explained all the steps, like basically creating the bespoke custom HVAC system, and you saw how it was like different components were connected and how flexible the system is to in order to build your or design your HVAC network. Now, what we are currently also working on is how to simplify this entire process using AI assisted workflow. And a short glimpse of that, I'll just give you how this entire thing works that I showed right now, how it basically works through. Uh, so the whole workflow is the same. We have AI assistant basically within the canvas, in which you are, instead of drawing them manually, you are loading the templates through chat with the assistant and modifying them with quick commands in the chat window. So it's a agentic workflow which through which you talk or chat with that workflow, and it's generating the entire HVAC network rather than spending time on manually dragging, dropping the components, changing their properties. Everything is basically operated through chat, and it updates the canvas. So the process of building the network also is now simplified, and almost 50% of time saving is achieved because of this. So this whole process is AI assisted through our agentic workflow. So like you see, it's updating as we basically give different options in the chat window. It's as easy as basically chatting and creating your HVAC network. So this will be released in steps. Like first we'll be releasing the manual HVAC canvas and then releasing the HVAC assistant along with that. So I think for the demonstration purpose, that is what I had going. Yeah. Some concluding slide of the tool features. Basically, right now, what can you model? So what we focused today was on the modeling side of HVAC systems. So we have different air handling systems in the library, starting from single duct AHU, dual duct AHU, dual dedicated outdoor air systems, their extensions. We have the plant systems in the library, a whole bunch of heating, cooling, condenser plants, solar as well as VRF. We also have terminal units like fan coil, chill beam, then the VRF refrigerant flow terminal units, and some sustainable equipments are also available in the library right now. A very important feature of grouping the zones so that you don't work on one zone at a time and repeat the operation, that is there. And a user doesn't have to start from scratch creating their network. So they can preload the existing templates and just edit whatever is required. And then coming soon features, which are basically the AI assistant, and many objects in the library will be populated, which will be coming next once we release these features. So I think, yeah, that is what from the tool side I have tried to cover. And if you have any questions, feel free to drop in the chat as well as get back to us later. So I'll basically hand over to Manas now to give the concluding remarks on this webinar. And thank you all for attending. And thanks, Surbi, for giving a very important and critical insights into HVAC system and their importance in the building design.
Thank you, Swapnil. Yeah. I mean, the tool seems promising, and I'm hoping to explore more of it.
So Manas, I think you can take over from here. Thanks.
Yeah.
Thanks, sir.
Yeah.
Thank you,
Swapnil. Thank you, Surbi. Swapnil, we have some questions in the chat if you can see them, if you'd like to answer them. We also invite the attendees to ask any questions you might have.
Yeah, just let me. Would you like to go one by one, or how do you want to let me just have a quick look at it?
Sure.
So I see one question, which is basically how to get the tool, any pre-requirement for purchase. So I think what we have like for all webinar attendees, we have extended trial offer, and our team will get back to all webinar attendees to get their trial version, which is well beyond a month. And you can try out various features, give us your feedback. And if it fits your requirement, we can send you the details of the subscription plans. Manas, are you able to see more questions? Because I'm not able to see.
You can go to more in your toolbar. There's a question and answers window. You can see that.
Okay, got it. Okay, so first question from that list is, how does buildings AI differ from traditional tools like I'll not probably name it, but yeah, I mean, I'll try to answer it as a generic. So, buildings AI differs in mainly three areas. One is multiple options to bring in your input building geometry and the ease of bringing them in. Second is we have a main focus on visualization. So whatever you do, we try to give a visualization feel to the user, be it bringing in the CAD model for the building, dealing with your space types, zones, and also creating custom HV systems. So we have a visualization feature for each and every step. And the last one is basically incorporating AI-assisted workflows as well as agentic workflows to do the manual steps, which save 50% of the time. So this is what our focus has been in terms of what value we bring in the tool.
And just to add to what Swapnil mentioned, I would say in terms of accuracy, just to share the piece of information, the tool is actually using an Energy Plus engine in the back end. So accuracy is as good as it can get. But how is it different? I think in terms of my experience as an energy modeler, I feel that once it is, most modules are released, the workflow will go much smoother, and the tedious job of getting input in, and the QC process, all time consuming aspects of energy modeling would get reduced. And as an energy modeler, I think you would have more time to spend to analyze the results and to reassess what could be other additional energy efficiency strategies that you could test. So I think that's one of the things I feel would be an edge, because we would have reduced the time in inputting data into the model.
Right. Yeah. Yeah. I mean, that's thanks, Ruby, for highlighting that critical aspect. Right. Let me go to next question. Yeah, it is. The question is, how are control strategies incorporated into the simulation? So right now we have control strategies in the form of set point schedules, which are also for the I would say the components of the HVAC network that you create. So you have features there where when you drag and drop the components into your HVAC network diagram. And we also have control strategies for the individual zones or the space types that form the building model. So both are there, and you can edit both of them in the respective sections. Next is how does Buildings AI capture and update HVAC loads when there are frequent architectural changes like layout, glazing, orientation? And is there an automated workflow to sync updates from Autodesk Revit so that remodeling efforts is minimized? So the first part of this question is how does frequent changes are handled? So right now the way to do it is save them as different configuration and run them for your HVAC or energy calculations. And since they are basically calculations are done on cloud, they are as fast as you can run 10 different configurations altogether. There is no restriction. And for Revit sync, we bring in Revit model as an import. So there is no reverse sync right now, but if you update a Revit model and bring in with the import tool, your updated model reflects in the building configuration. But that is how it is. There is no real-time reverse sync right now or something like that. Like you change a particular component, it directly reflects in your existing model. No, I mean that feature is not there. But you start off from a new import, and that import is pretty fast. So that I think that would be our solution at this point for this particular workflow. Uh, Next question is, as a person interested in to join HVAC industry, what all skill does one need to make a career in HVAC industry? I think Surbi, with her vast experience, would be the right person to answer this or give a quick direction to this question. Surbi, would you take this?
Yes. So in terms of HVAC industry, if you have already completed your mechanical engineering degree, then you're already set up for that. Depending on which country you are from, there are different licenses that you can work towards. I would say overall, if you are thinking of joining the building energy efficiency industry, there are good credentials to get for yourself would be a lead in general. And if you are particularly interested in energy modeling, ASHRAE has a credential called BEMP. That's very highly regarded, and you can also shoot for that. And then there are a lot of other credentials as you move up in your career. So I think those two must be a good place to start.
Thanks, Survi, for that response. And I think one more we'll take. Is it compatible with eQuest? So I did not understand exactly what you mean by compatible, but what I can tell is since the tool is based on Energy Plus as a simulation engine in the back, or the calculation engine, all the raw files of Energy Plus, including the GBXML file of the setup, will be available in the project or the file data hub. So if that answers your question, I mean, that's what we have right now. Then I think there are a few more questions. One more I'll take is the tool, okay, is this tool can be used for designing HVAC system for data center cooling? Uh, Okay, there I think the answer to this is in the form of yes and no, both. But what the common library is available. You can basically design HVAC system, but right now we don't have a way to handle the exact geometry for the data center. What we have worked in past as a custom solution for few of our clients is to come up uh, uh, with a data center extension for this tool, which helps to calculate different parameters for data center. But yeah, I mean, you could do a HVAC network with a few additions in the library, and if you have a urgent, like immediate requirement for this, we could talk later in a follow-up call. We can develop a custom version of this tool for regular use for data center applications. So another one is how to check for baseline and proposed comparison. Do we have to create two different models? Yeah, I mean, right now you'll need to create two different configurations, solve them together, and analyze the results separately and compare. That's what we have. We are coming up with design scenarios. The feature is not yet there in the tool. In future, it will be available. So I think, Manas, I've come to the end of questions.
Right.
If you can see any more questions, probably we can get back by email.
Right. Right now, I don't see any additional questions.
So you can continue and probably conclude with additional information.
Right.
Hi, so Surbi here. I see one more question, which is about can I generate reports for compliance, lead and energy code compliance report. So from what I know, while talking to Swapnil and Aditya, I think Buildings AI is in the process of doing that, and it's one of the next steps, I would say. Do you want to add to it, Swapna?
Right. Yeah. Right. So right now we have a custom template based on the climate zone, which is a report template which is exported. But in terms of lead summary and lead analysis, we still don't have a ready module. We are coming up in that in future about that.
Right.
All right. Thank you, Swapnil. Thank you, Surabhi, for answering the questions. Thank you to the attendees for sending in your queries. I'll just quickly go over how you might access this our software. So we have a 15-day free trial that you can access. If you go to simulationhub.com, you can get in touch with us. You can request a demo or arrange a call with our product experts. In particular, if you're a student, we also have a special offer. This will be especially useful if you are participating in the ASHRAE design competition of 2026. You can get an extended 2-month trial for Buildings AI. It will cover peak load calculations, HVAC analysis, and net zero energy design. So you can scan this QR code. I'll hover on it for a minute. It will take you to the free trial. You should also be able to find this on our website. Additionally, I just want everyone to know that Simulation Hub and CC Tech, we are an organization of 200 plus engineers. We have expertise in CAD, simulation, sustainability, and we have AEC industry expertise. If you have a custom requirement, you can get in touch with us again through the Simulation Hub website. For custom requirements and projects, we can use our Buildings AI API and create a tailored solution. So thank you all. Thank you to our speakers, Swapnil and Surabhi. Thank you for attending. You can get in touch with us. You can connect with our social media platforms. Yeah, thank you very much for attending. Have a good rest.